Hello guys, I'm Mr. Idris. I'm back again with another video lesson. I hope you are all doing well. And in the previous lesson, we stopped it here in question 44, review and assess. And if you remember in the previous lesson, we studied RLC series connection, resistance, inductance, and capacitance in a series connection. And you have to know in series connection in electric circuit, the value of the currents are equal. I total is equal to current across inductance, resistance, and capacitance. And question 44, guys, this question is very good question. Pay close attention for this question and review and assess. The question says 100 watt and 120 volt bulb is to be operated under a potential difference of effective value 240 volt and frequency 50 hertz. So at first, you have to draw the circuit for this light bulb. The bulb is a resistance. Guys, be careful, okay? Bulb, in this question, what do you mean by the light bulb? It means that this is resistance, okay? What is this? This is resistance. And this resistance, the bulb, is connected with AC source, okay? And the V effective, VE total is 20 volt, okay? And the power that dissipated in this light bulb is equal to 100 watt, okay? But we don't know what is the resistance of this bulb and what is the current of the bulb, okay? How much current dissipated in how much current passes through the resistance. But by knowing power and potential difference, we can determine what? Each of the resistance and the current, okay? Before solving question, you have to find resistance and the current, because in this question we need both resistance and current. How can you determine resistance, or how can you determine current in this bulb? By using the equation of power. Power is equal to what? I times V, okay? I.e. VE. I is equal to what? I.e. power over effective potential difference. Do we have power? Yes, 100. Divide by what? The potential difference, which is 120. Sorry, this is not 20, this is 120. Okay, divide by 120. Current is equal to what? The current is equal to 0.83 ampere. What is this? This is the value of the current that passes through this bulb, which is equal to 0.83 ampere. Now we have current, but we have to find the resistance of this bulb, okay? What is the value of the resistance of the light bulb? The value of the resistance of the light bulb is, how can you determine? By using this relation. Guys, look. Power is equal to what? Is equal to I squared times R. R is equal to what? Is equal to power divided by I squared. Do we have power? Yes. I.e. we didn't have, but we found 0.83. which is equal to 144, okay? 144 ohm. This is the resistance of this bulb. And also you can determine resistance in another way, as you can see here. Guys, power is equal to what? VE squared over R. R is equal to what? R is equal to power, VE squared divided by power. Do we have VE? Yes, 120 squared divided by 100. Resistance is equal to still 144 ohm. So in this question, now we have both resistance and the current. Okay, let's continue the question. Under the potential difference. So this resistance now connected with another source. This is the second source, guys. But in the second source, VE total is equal to what? 240 volt. In the first circuit, we found both resistance and the current of the light bulb. Okay. Now we have to remove the light bulb from the first circuit, and we have to connect it with the second circuit. In the second circuit, the potential difference of this circuit is 240 volt, okay? Now, the light bulb is connected with the second circuit. What is this? This is the second source and the second circuit. Do we have resistance? We didn't have, but we found. is equal to 144 ohm. Do we have current across the resistance? We didn't have, but we found 0.83, sorry, 0.83 ampere. Okay, VE total of the source 240 volt. Frequency 50 hertz. Frequency is equal to 50 hertz. Calculate the capacitance of capacitor. What is unknown? The capacitor of capacitor. The capacitance of capacitor. C. What is unknown? C is unknown. That should be connected in series connection. In series connection, IR is equal to IC is equal to IE total. Now in this circuit, what we have? We have a capacitor. We have what? Capacitor. In this circuit, we have both resistance and capacitance. Okay, this is R and this is C. Do we have the value of resistance? We didn't have, but we found 144 ohm. Do we have the capacitance of capacitor? No, it's unknown. We have to find it, okay? How can we determine the capacitance of capacitor? The capacitance of capacitor is equal to, like, by using this relation, XC is equal to what? 1 over 2 pi FC. Guys, be careful. Only in this equation we have capacitance of capacitor, okay? So you have to rearrange this equation to determine C is equal to what? 2 pi F XC. Do we have frequency? Yes. Do we have XC? No, we don't have XC. Now, without XC, we cannot find the capacitance of capacitor. So that is why we have to try to find XC. How? By using the relation of total impedance. The total impedance, guys, look. Z is equal to what? In this circuit, what we have? We have capacitance and resistance. Do we have inductance? No. Do we have coil? No, we don't have coil. We don't have XL. We don't have VL. We don't have IL. Okay, so that is why we have to remove XL, VL, and IL in all equations. Z is equal to what? For the circuit including capacitance and resistance is equal to R squared plus negative XC squared. Okay, so negative square, it's still is positive, okay? So that is why it's not necessary to write down this negative, because negative square, it's still positive. XC, sorry. XC square. This is the equation of total impedance, okay? Do we have the total impedance? No, we don't have Z, okay? How can you find XC without Z? We cannot. How can you determine Z? Z is equal to what? VE total over I. Because the circuit series connection, the IE total is equal to I across resistance, I across capacitance. Okay? Do we have, what is this? This is current across resistance. Is equal to IE total? Yes, because it is series connection. Do we have VE total? Yes, 240 divided by 0.83. Z is equal to what? Z is equal to 289 ohm. 289 ohm. Now, do we have Z? Yes. Square both sides to remove this radical. The Z becomes what? Z square. Radical remove with the square. What does remain? R square plus XC square. Rearrange. To find XC square, take R to the other side. It becomes negative. Okay, now XC is equal to what? Z square minus R square. Just we rearrange it. Okay, now we have to replace the number. XC square is equal to what, guys? Remove this square, take the square root for the other side. Z square minus R square. Do we have Z? We didn't have, but we found Z 289 square minus, do we have R resistance? We didn't have resistance, but we found 144. Guys, how did we find resistance? By the power and the potential difference of the bulb. Okay. Now by calculator you can get the final result of XC, which is equal to 251 ohm. What is this? This is XC. Now we have to replace into this equation. Replace XC, the value of XC into this equation. Guys, look, C is equal to what? 1 over 2 pi times 50, times XC, 251. 251. C is equal to what? Is equal to 1.3 times 10 power negative 5 farad. Or you can say 13 microfarad is the same thing. Okay? This is the final result of the capacitance of capacitor in this question. It's a very good question. You have to pay close attention for the question like this. Question 45, guys, be careful. In question 45, we have some notes before solving this question. If direct potential difference DC or alternating potential difference AC is given in the question, use the following. With the DC source, we have to find, for the coil, we have resistance, we don't have XL. But for in AC source, the total AC and current, total current of AC, we have to find Z. It means that this is the total impedance, okay? In DC current, the coil has only resistance. Guys, if you remember, if you have a coil, what is this? This is coil, okay? The source is DC. What is this source? This is DC source. In DC source, only we have resistance, but we don't have XL. Guys, be careful. XL in DC source is equal to 0. The total impedance only exists with the AC source, okay? Because the total impedance, they resist the change in the current, okay? So we don't have change current in DC source. So that is why we don't have XL. But AC source, if you have coil with AC source, okay? If the coil is not pure, okay? Like coil is not pure. Coil not pure. It means that we have resistance and we have impedance, inductive impedance. We have both. But with DC, only we have what? We have resistance. How can you determine the resistance of this coil? Resistance is equal to what? We have maximum potential difference and maximum current, which is equal to VL over IM. In DC source, only we have maximum values. We don't have effective, we don't have instantaneous, okay? In DC source, we have only maximum potential difference and maximum current. But in AC source, we have effective current, effective value of potential difference and current, maximum value of for both of them, instantaneous value for both of them, okay? Let's solve the question, guys. Question 45, a coil of cell of inductance. A coil of what? Cell of inductance. So it means that you have to draw the coil. The cell of inductance and the coefficient of cell of induction is equal to 50 millihenry. L is equal to what? 50 times 10 power negative 3 Henry. It's traversed by a current of intensity 2 ampere. The current is 2 ampere. Under direct potential difference, it is that both the current and potential difference VDC is equal to what? Is equal to 20 volt. Okay? So it means that this coil now connected with what? With DC. Now the coil is connected with what? With DC source. How did you know? Because it's mentioned in this question. Direct potential difference. Direct. What do you mean by direct potential difference? It means that DC battery. Okay, what is this? This is the DC of battery. What is the value of this DC? The potential difference is 20 volt. Okay, guys, coil in DC source has only what? Only resistance. Do we have XL? No. With DC, we don't have XL. We have only resistance. Now, can we find resistance of this coil? Absolutely yes. Resistance is equal to what? Is equal to maximum potential difference over maximum current. R is equal to what? Maximum potential difference 20 divided by 2 R is equal to what? 10 ohm. Now, do we have resistance? Yes. 10 ohm. Guys, if you remove this coil from this DC source and connect it with the AC source, what happened to the resistance? It doesn't change. Resistance is the same. It doesn't matter this coil is connected with DC or AC. Okay. Now, do we have resistance? Yes, we have resistance. Okay. L 0.2 times 10 power negative 3 Henry. Resistance we didn't have, but we found. Okay. Find the maximum value of the current. What is unknown? Maximum value of the current. This is very good question, guys. Pay close attention, please. The maximum value of the current in the coil when connected across AC source. When connected across what? The second time. The first time the coil was connected with DC in order to determine what? The value of resistance of the coil. But in the second time, the coil is connected with what? With AC source. The second time, the coil is connected with what? With AC source. Okay? Do we have resistance? Yes, 10 ohm. Do we have XL? Yes, we have XL, but we don't know. Okay? So the value of the effective potential difference is equal to what? 20 volt. Okay? And frequency is equal to 60 hertz. Is equal to 60 hertz. Okay. Now, in this case, in this circuit, because the circuit is connected to AC, for the coil we have both XL and resistance. But at first we didn't have resistance. We found resistance by using the DC circuit and DC source of the circuit. Guys, how can we determine the maximum value of the current? For solving this question, you have to make the plan. Okay, the plan of this question is there is a relation between maximum and effective value of the current. It's like this: IM is equal to what? Is equal to IE times radical 2. IM total is equal to what? IE total times what? Times radical of 2. Okay. Now, guys, look, L was given, and the total current of the DC source at first was given to determine the resistance. Okay, guys, how can we determine IE total? IE total is equal to what? IE total is equal to VE total over Z. Okay, do we have VE total? Yes, but we don't have Z. How can we determine Z? Z is equal to what? R square plus XL square. Do we have resistance here? The coil is not pure. Guys, in this question, the coil is not pure. The coil has resistance. We have both resistance and inductance. Okay, what is this resistance? This is the resistance of the coil. Do we have resistance? Yes, 10 ohm. Do we have XL? No, but we can find XL. How? XL is equal to 2 pi FL. XL is equal to what? 2 pi FL, which is equal to 18.86. Replace in this equation R 10 square plus 18.86 square. Z is equal to what? Z is equal to 21.34. 21.34 ohm. Replace into this equation in order to find what? Current, IE total. VE total, 20. Z we didn't have, but we found 21.34. Now, IE total is equal to what? IE total is equal to 0.937 ampere. What is this? Is this maximum value of the current? No. So we have to find what? Effective or maximum? Maximum. Is the maximum value of the current is equal to the effective value of the current? No, absolutely no. It's different. There is a relation between maximum current and effective current. Replace into this equation in order to find what? IM total. IE total 0.937 times what? Times radical 2, which is equal to 1.33 ampere. What is this? This is the maximum value of the current. Question 54. Guys, look at this question. Okay. Question 54 in review and assess. Given an AC source of instantaneous potential difference, the equation is given in this question, guys, be careful. The equation of potential difference and instantaneous potential difference is equal to 100 radical to sine 100 pi t. Okay, so the number before sine is always, for the equation of potential difference, is maximum value. Do we have maximum value? Yes, is equal to what? 100 radical to. So the number before t, before time, is equal to what? Omega. Do we have omega? Yes, 100 pi rad per second. In the equation, we have two values: maximum value of potential difference and the angular speed of this circuit, which is equal to 100 pi rad per second, omega. Okay? A pure resistance of the circuit. Do we have resistance? Yes, is given 20 ohm. Of cell of inductance, L, 3 over 5 pi Henry, and negligible resistance of the coil. What do you mean by negligible resistance of the coil? It means that the coil has no resistance. We have only pure resistance. Be careful, guys. We have two different types of resistance: pure resistance of the circuit and the resistance of the coil. This is two different things. Be careful. The resistance of the coil, it means that the resist of the coil, okay, which is the coil is not pure. But the resistance of the pure, it means that the resistance of the pure resistance, like a light bulb, is connected with the circuit. Okay? And the capacitor of capacitance, C, is given 1 over 4,500 pi farad. Are all connected in what? In series connection. Guys, you have to know the connection is series or parallel. It's very important, okay? Calculate the following. The inductive impedance of the coil, XL. Capacitive impedance, XC. And the total impedance, Z. What is unknown? XL, unknown. XC, unknown. The total impedance, unknown. How can you determine XC, XL at first? XL is equal to what? 2 pi FL or omega L? Omega L. Why? Because we have omega, not frequency. Is equal to what? Omega L. Do we have omega? 100 pi. Do we have L? Yes. 3 over 5 pi. XL by calculator is equal to what? Is equal to 60 ohm. Okay? Pi with pi cancel. 3 times 100, 300 divided by 5 is equal to 60. XC is equal to what? XC is equal to what? 1 over 2 pi FC or omega C? Omega C, because we have omega and C. Omega 100 pi, C 1 over 4,500 pi. Pi with pi cancel. XC is equal to what? Is equal to 45 ohm. And then we have to find Z, the total impedance. Z is equal to what? Because in the circuit we have resistance, capacitive impedance, and inductive impedance. That is why we have to use this relation. R squared XL minus XC squared. Replace R was given 20. XL we didn't have, but we found 60 minus XL. XC also we didn't have, we found. Both of them subtract and square. Z is equal to what? Z is equal to 25 ohm. Very easy question. This is branch A. Okay, in branch A, what is unknown? We found 3 unknown. The impedance of the coil, capacitive impedance, and the total impedance. Branch B, the effective current of the circuit. In branch B, what is unknown? The effective current of the circuit. The effective current of the circuit, it means that IE total. What is unknown? IE total is equal to VE total over Z. Guys, do we have VE total? No, but we have the maximum total. Okay? Can I put the maximum value in this equation? No. We have to find VE total. How can I determine VE total? VE total is equal to what? VM total divided by radical 2. Do we have VM total? Yes. In the equation was given 100 radical 2 divided by radical 2. Radical 2 with radical 2 cancel. VE total is equal to what? 100 volt. Now we have to replace into this equation. Okay? 100 divided by 25 is equal to 4 ampere. What is this? This is the effective value of the current. What is this? Effective value of the current. Can you find the maximum value of the current? Yes. IM is equal to what? Is equal to IE times radical 2, 4 radical 2 ampere if it is ordered to find it. Okay? So that's it for the question 54 in RLC series connection to AC circuit. Guys, the last question in RLC series connection, the last question, question 55 in reviewanalysis. So the question says, a capacitor of capacitance, 400 microfarad. C, 400 microfarad times 10 power negative 6. Convert to farad. It's not allowed solving with the micro with the prefix. Connected with what? Connected in what? In series connection. Pure resistance is equal to 10 ohm. Okay, it means that we have capacitance, resistance, and yeah, I think we have only capacitance and resistance. Okay. Across AC source of frequency, yeah, we have only resistance and capacitance across connected with the AC source. This is capacitance and this is resistance. And both the capacitance of the capacitor and the pure resistance are given in this question. The frequency of the source is equal to 250 over pi hertz. So what is this? This is the frequency of this source. If the effective value of the potential difference across capacitor. What is this? This is the effective value across the capacitor, VEC. VEC, what do you mean by VEC? It means that the effective value of potential difference across what? Across capacitance. Okay? VEC is equal to what? 80 volt. Okay? Find the effective potential difference across the pure resistance. Find what? Effective potential difference across what? Pure resistance. VER. What is unknown? VER. VER is unknown. Okay? How can we determine VER? Branch A. Let's solve branch A. Guys, VE, effective value potential difference across resistance, is equal to IER times R. Do we have R? Yes. But we don't have I. Because the circuit is series connection, IE total is equal to IER IEC. Okay? Now, can we find IEC? Yes. Why? Because IEC is equal to VEC over XC. The relation of capacitive impedance, XC is equal to VEC over IC. IEC is equal to what? VEC over XC. Do we have VEC? Yes. Effective value of potential difference across capacitance? Yes. But we don't have XC. How can we determine XC? XC is equal to what? 1 over 2 pi FC. 1 over 2 pi times 250 over pi times 400 times 10 power negative 6. Okay? XC 1 over 2 pi FC, 1 over this number by calculator is equal to what? 5 ohm. XC is equal to what? 5 ohm. Replace it to this equation to find what? Effective value across the capacitance. VEC was given. XC we didn't have, we found. 18 divided by 5 is equal to 3.6 ohm. Ampere. Because the circuit was connected in series connection, all values of the current across resistance, capacitance, total are equal because it's series connection. Now, can we say this IER is still 3.6? Yes, of course. VER is equal to what? IER? 3.6 times 10, 36 volt. This is potential difference across the resistance. Across what? The resistance. Branch B, find the maximum value of potential difference of the source. The value of maximum value of potential difference across the source. Guys, be careful. How can I determine maximum value? Maximum value is equal to VE total times radical 2. Okay? Do we have VE total? No. V effective total is equal to what? Is equal to IE total times Z. Okay? So do we have Z? No, we don't have Z, but we can find, sorry, we cannot, yeah, we can find Z, but it's too complicated. In another way, guys, VE total is equal to what? VER square plus VEC square. VER 36 plus 18 square. VE total is equal to what? VE total is equal to 40.24. 40.24 volt. How about V maximum? So you have to replace this effective value into this equation in order to find what? V maximum. V maximum total now is equal to what? This number, 40.24 times radical of 2. V maximum total is equal to 56.92 volt. What is this? This is the maximum value of potential difference, okay, across the source. Branch C represent vectorially the potential difference across the resistor. Potential difference across what? The resistor VR, VC, and source, VE total. Because in this circuit we have only resistance and the capacitance. We know that in pure resistance we have VR here. In pure capacitance, VC lags behind the current. Okay, so that is why the figure should be like this. And the V of the source, VE total, this is VE total. Okay? And this is the angle between VE total and V across the resistance. And this angle is the angle between VE total and V across the capacitance. Okay, vectorially, the figure between V across resistance, across capacitance, and the source, it should be like this. Okay? Guys, we finished RLC series connection. Resistance, inductance, and capacitance in series connection to AC circuit. In pure resistance, just for reminding you, in pure resistance, there is no phase difference between the resistance and between the potential difference and the current. Both the reading of voltmeter and the ammeter both increases and decreases together. The value of potential difference, when value of potential difference reaches 0, the current also reaches 0. When the potential difference reaches maximum, current also reaches maximum in pure resistance. Okay, so the power dissipated is follow Joule's law. The energy is generated, okay, because we have power dissipation. In pure inductance, if you remember, in pure inductance, potential difference VL leads the current by phase pi over 2, okay, or 90 degree, okay. And in pure capacitance or capacitor of capacitance, potential difference lags behind the current, okay. Now we are focusing on the RLC parallel to AC circuit. RLC parallel to AC circuit. Okay, it's very important, be careful. Okay, guys, in parallel circuit, so you have to keep in your mind, in parallel circuit, VE total is equal to VER, VEC, VEL, but it's not equal to V maximum, be careful. But maximum value also equal V maximum total, V maximum across resistance, V maximum across capacitance, V maximum across the inductance. These two terms are not equal. They are not equal to each other, be careful. Okay? So the value of potential difference are equal in parallel connection. Okay? So how about the current? But the current is not. We have to find the current, okay? So the phasor diagram for the current, it will be like this. Guys, be careful. In pure resistance, you know that IR, VR in phase. In what? In pure resistance. We don't have phase difference. Phase difference is 0. Okay? There is no lead and lag between potential difference and the current in pure resistance. How about for the pure inductance? So what is the relation between the current and potential difference in pure inductance? If you remember, in pure inductance, potential difference VL, lead is current. What about current? Current lag is behind potential difference. Current lags behind what? This is current IL. Lag is behind what? Behind potential difference across L. Current in pure inductance, current lag is behind potential difference. Or you can say potential difference leads the current by pi over 2. For the capacitor of capacitance, potential difference lag is behind the current. Or you can say current leads the potential difference. Current IC leads what? Leads the potential difference across the capacitance. Okay? Potential difference across the capacitance. So this is VL, okay? This is, this is IL. Okay? The value of the potential difference are equal in parallel connection to AC circuit, okay? Now we have to find what? IE total. By using Pythagorean theorem, IE total is equal to what? How many vectors do we have here? 2, IC and IL. IC with IL, the angle between them is 180. Angle between them is what? 180. How can you find the summation of these two vectors? We have to subtract them. Why? Because IC is upward, IL downward. Because of the summation of the two vectors in opposite direction, it becomes what? It becomes IC minus IL. What is this? This is the vector addition or vector summation. Okay. This is angle. Angle between what? IE total and potential difference. IE total, or you can say VE total. What is this? What is this angle? This angle between the total effective current and the total potential difference. Or you can say this angle is the angle between IE total and I across R. I across what? Across the resistance. Okay. IR is adjacent. Here is opposite. By using Pythagorean theorem, guys, IE total is equal to what? Is equal to IR squared plus IC minus IL. Be careful. IC minus IL squared. What is this? This is the equation to find IE total. Okay. When IR, IC, IL are given in the question, you can use this equation by using Pythagorean theorem in order to find IE total. Another equation to find IE total is equal to what? VE total over what? Over Z. In these two equations, we can find IE total. So how can you determine the angle between IE total and potential difference? IE total between I across R, theta is equal to what? Tan inverse opposite IC minus IL over IR. Okay, so how about the angle between IE total and IC? IR becomes what? Becomes opposite. IC minus IL becomes adjacent. To find angle between IE total and current across capacitance, IE total with IC, you have to use this relation. Tan inverse IR square opposite, which is IR, over IC minus IL square. Okay? In this way, you can find the IE total and IE and the angle between IE total with IR or IE total with IC. Okay? Guys, in parallel connection, this is AC source connected with resistance, inductance, and capacitance. So this type of circuit is parallel connection. Okay, what is this? This is parallel connection. We have IR, R, VR, IL, VL, XL, or L. We have IC, VC, C, or XC. Okay, and what is this? This is VE total, or this is IE total, and frequency. In parallel connection, guys, VE total is equal to VE across R, VE across L, VE across C in parallel connection. But current, IE total is not equal to IER, IEL, IEC. Is equal to what? Is equal to IR squared plus IC minus IL squared. Okay? And guys, current across resistance is not equal to current across inductance and not equal to current across capacitance. I, according Ohm's law, I is equal to what? V over R. IR is equal to VR over R, VL over XL, VC over XC. Okay? But all VR, VL, VC are equal, same. They are the same. Okay? How about I total? I total is equal to what? VE total over what? R, XL, XC, or Z? Z. Why? Because with total, we have to use Z, the total impedance. It's not allowed with total right down here, resistance or XL or XC. Is it clear? Yalla. And now we have to find the total impedance in parallel connection. It's very important, be careful, guys. The total impedance in the parallel connection, guys, look. Z is equal to what? Started from this equation. I is equal to what? IE total is equal to what? IR squared. IC minus IL squared. Okay? And guys, IE total is equal to what? VE total less Z. Over Z, sorry. IR, VR over R. IC, VC over XC. IL, VL over XL. Replace into this equation. Guys, look. And instead of IE total, write down what? VE total over Z. VE total over what? Z. Instead of this one. Radical. And instead of IR, write down what? VR over R. VR over R squared. Plus. And instead of IC, write down what? VC over XC. Minus. And instead of IL, VL over XL squared. Because in parallel circuit to AC circuit, the value of VE total, VR, VC, VL equal. That is why all they cancel each other. What does remain here? 1 over Z. What does remain here? 1 over R squared. 1 over what? XC minus 1 over what? XL. All of them squared. What is this? This is the equation of total impedance. But this is 1 over Z, 1 over total impedance. The question says find the total impedance, not find 1 over total impedance. So we have to flip this equation. If we flip this side, we have to flip the other side as well. Okay? If we flip 1 over Z to Z over 1, it becomes what? Z. And if we flip the other side, it's going to be 1 over the radical. 1 over R squared. 1 over XC minus 1 over XL squared. This equation can be used to determine what? The total impedance. Okay? This is the equation of what? Total impedance in parallel connection. In what? In parallel connection. So I suggest for you to not memorize the all equations. Okay? Because you cannot memorize all the equations. So you have to understand, you have to prove the equations one by one. Okay? And you have to draw the figure. After that, by using Pythagorean theorem, replacing by the Ohm's law. Okay, it's very easy if you understand, okay? Guys, if you remember, XC is equal to what? is equal to 1 over omega c. And instead of xc, write down 1 over omega c. Z is equal to what? 1 over r square plus 1 over, and instead of xc, write down what? 1 over omega c. Reciprocal math basic, it's gonna be what? Omega c. Because 1 over omega c is equal to omega c. Minus 1 over xl, it's gonna be what? 1 over omega l square. This equation also is correct. Which one is correct? Both. The same thing. This equation basis from this one. Okay? Another equation of total impedance. Guys, you know that omega c is equal to 1 over 2 pi fc. Okay? Is equal to what? 1 over 2 pi fc. Because omega is equal to what? 1 over 2 pi. Okay? Guys, look. Yeah, omega c is equal to, yeah, it is not necessary to write down because omega c is equal to 1 over 2 pi fc and omega l is equal to 2 pi fl. You can replace, okay? And you can replace from this equation. Z is equal to what? Look. I didn't write here, but I'm going to write here. 1 over, sorry. 1 over radical r square plus xc is equal to what? 1 over omega c. Omega c is equal to 1 over 2 pi fc. It's going to be 2 pi fc, okay? Minus 1 over 2 pi fl square. Also, this one is correct. You can use this relation when frequency, capacitance, and coefficient of self-inductance are given in the question, okay? As usual, if the circuit consists only of resistance and inductance, you have to remove all IC, XC, and VC. But if the circuit is including only resistance and capacitance, you have to count only for the capacitance and the resistance. If XL bigger than XC theta, it becomes positive. Okay, and if IC is bigger than IL theta, is also is positive. Mathematically, you can find out this value. Okay, in pure resistance, in phase, in pure inductance, potential difference leads, which means current lags. In capacitance, current leads the potential difference. Okay, look at sample problem. Question 56 in review and assess. Very good question about the parallel circuit. We have only this question in parallel series, a parallel connection to AC circuit of resistance, inductance, and capacitance. We have only one question. Okay, question 56. An AC source of effective value VE total is equal to what? Is equal to 50 volt. It's connected across parallel combination of resistance. R is equal to what? 300 ohm. Inductor of inductance, which is XL, is equal to 600 ohm. And the capacitor of impedance, XC, is equal to 200 ohm. Okay? Calculate the following. A, impedance of the circuit. What is unknown? A, Z. How can you determine Z? Guys, look. Z is equal to what? In parallel, because the circuit is parallel combination, we have parallel connection. Z is equal to what? 1 over R square, 1 over XC minus 1 over XL square. Z is equal to what? 1 over R 300 square. 1 over XC 200 minus 600 square. Z is equal to what? By calculator, you will get this number 212 ohm. Okay, what is this? This is Z. This is branch A. Branch B, what is unknown in branch B? Effective value of current IE across what? Pass through the resistor, IER, IEL inductor, sorry, IEL and IEC. What is unknown? The effective value of the current across each of the resistance, inductance, and capacitance, which is IR, IL, IC. How can you determine IR? V over R. IL, V over XL. IC, V over XC. Because it is parallel connection, the value of potential difference are equal, which is 50, 50, 50, 50. R, 300. XL, 600. XC, 200. Look. IR, 500 over 300. 50 over 300, sorry. 0.166 ampere. IL, 50 over 600. IC, 50 over 200. Okay? Branch C, guys, branch C. What is unknown in branch C? The value of effective current of the circuit, IE total. What is unknown? IE total is unknown, which is equal to VE total over Z. VE total still 50. Z, we didn't have what we found, 212. IE total is equal to what? IE total is equal to 0.235 ampere. Okay? The last branch, branch D, branch D, guys, be careful. Branch D, what is unknown? There is a difference angle between total current and total potential difference. IE total, VE total. Angle between these two things, okay? Let's go back to the previous slides. Guys, look. Where is the angle between IE total and VE total? This is IE total and this is VE total. This angle is unknown. This angle is equal to what? IC minus IL over IR. Angle is equal to what? Tan inverse IC minus IL over R. Do we have IC? We didn't have, but we found 0.25 minus IL 0.083 divide by IR 0.166. Theta is equal to what? Tan inverse is equal to 1, which is equal to 45 degrees. Okay, the current lead is potential difference. Why? Because IC is bigger than IL. That is why the current lead is behind the lead is the potential difference by this phase. Okay, so that's all for the RLC series connection and RLC parallel connection to AC circuit. Inshallah, in the next lesson, we will study the oscillation circuit and the resonance in electrical resonance. Okay, thank you for listening. Keep up your best doing. Have a good time.